The square root of a number is written like this. So you said it's the square root of a. Per definition, that's the number you should put here. So when you raise it to the power of 2, you will get a. So per definition, this is a symbol for number, and that's the number. If you put it here, that if you raise to the power of 2, it should give equal to a. So that's the definition of this. So what is, for example, the square root of 9? That's the number you should put here to make this work. So what number should you put here? So we raise to the power 2, you get 9. Yeah, that must be 3. So this is equal to 3. Of course, you could have put also minus 3 here. That will also make it work. But to have a unique definition, you define this as the positive, non-negative number that you should put here. So in this case, you have two options. You could put 3 and minus 3, but you define this as the non-negative solution, if you want, that you should put here. So this is equal to 3, not minus 3. And for example, square root of 16. That's the number you should put here, equal to 16. And here we have two options. We can put 4 and minus 4, but according to the definition, we should use the positive, or if it's 0, so non-negative. This must be equal to 4. And then, for example, square root of 0. That's the number you should put here. And that must be 0. So this is 0. We see that we cannot have square root of negative numbers. So for example, where is the square root of minus 9? This is not defined because there doesn't exist a real number that you can put here to make this work. Because if you square a real number, it will always give you a non-negative number. It can't give you a negative number. So this is not defined. At least if we don't go to complex numbers, but we won't do that in this course. So this is in our course is not defined. So for all negative roots, it's not defined. But if it's 0 or positive, it works. This can be generalized to, we are talking about square roots, but you can also talk about, for example, the cubic root. And then you write a 3 here instead. So if you take a cubic root of a, that's the number you should raise to the power of 3 to get a. So what should, for example, the cubic root, you call this the cubic root. What's the cubic root of 8? That's the number, if you raise it to the power of 3, you should get 8. And that must be 2. So in this case, you can also generalize it to cubic roots. And you can go further. You can, for example, define the nth root. So n here is 2 or 3 or 4 or 5. It's a natural number. So if you take the nth root of a, then per definition that means the number you should put here to make this work. So for example, what is the fourth root? The fourth root of 16. That's the number you should put here. And you see that here is 2 works. So this is equal to 2. Also in this case you have to choose the non-negative number, because the minus 2 would also have worked. But you choose the non-negative number to make this definition unique. So whenever you have a number here, the number n, that is an even number, you have to choose the non-negative one. But if you have an odd number, you don't have to make that choice, because in this case, this was equal to 2. In this case, minus 2 wouldn't have worked. So in this case, there is only 2 that is possible. So you don't have to make the additional comment that you should choose the non-negative one. So, for example, the cubic root of minus 8, this is defined. So now this works because this means the number you should raise to the power 3 to get minus 8. And then it works to have minus 2 here. So in this case, it's defined also for negative roots of negative numbers. So whenever you have an even number here, it's not defined for a negative number here, negative number a. But when you have an odd number on n, it's defined for a negative. And then of course we could also write a 2. So this is what we should raise to the power 2 to get a. But this is just what we had before. That's what we previously called this. So this symbol and this symbol is just two ways of writing the same thing. So if you have a 2 here, you don't have to write it out. You can leave it out. So if there's nothing here, it means 2. If it's some other number than 2, for example 3 or 4, you have to write it out. So that's a convention. This means the square root. This means we have a 2 here. Then we also can write down rules for roots. So you take the nth root of a multiplied by b. Then the rule says that this is the nth root of a multiplied by the nth root of b. For example, if you have the square root of 4 times 9, and now we don't have to write out the 2 here, since per convention then it means 2. So then according to the rule we should take square root of 4 and square root of 9. But square root of 4 is 2. Square root of 9 is 3. So this is 6. You can also check it if it's consistent here with this one. So this means square root of 36, because 4 times 9 is 36. And what is the square root of 36? Yeah, that's 6. So we get 6 here, either if you do it directly or if you use the rule. We can also have a similar rule for square root of a quotient. So if you have a divided by b, and we take the nth root of that, then we can take the nth root of a divided by the nth root of b. So for example, if we had a cubic root of a divided by 8 divided by 27, then according to this rule, we can take cubic root of 8 divided by cubic root of 27. And cubic root of 8, that is what you should multiply, raise to the power of 3 to get 8, and that's 2. And what should you raise to the power of 3 to get 27? Yeah, that's 3. So this is equal to 2/3. So then you also have a rule for division.